This video is for 7.2, question 4. Listed below are measured amounts of caffeine obtained in one 12-ounce can from 20 brands of soda. Use a confidence interval of 99%. Does the confidence interval give us good information about the population of all cans of the same 20 brands that are consumed? Does the sample appear to be a normal distributed population? If not, how do the results affect? So they give us a bunch of data. So in order for us to do this question in R, you have to enter all this data into a variable. So in this case, we was a vector. So we assign a variable, a vector x in this case, x equals to c. You can use any variables you want. And then you will begin to type in these numbers in there, 0, 0, 34, 34, 34, 45, 41, 51, 55, 36, 47, 41, 0, oops, typo, 0, 53, 54, 38, 0, 41, 47. And then we'll be using t.test in this case, so we are not using t-sum test. T-sum test is only used when the question provides us the sample mean, the sample selection, and the sample size. However, if a question provides us raw data like this, you will use t-sum test, x, which is the variable or the vectors we're using here, and conf level in this case is going to be 99.99. So this is a confidence interval for this case. So for a 99% confidence interval, it is between 19.54 to 45.56, and the units in this case is these are all about caffeine, so they are measured in grams, I believe. Yep, they're all measured in grams. Usually I will provide you the unit in this case. And then, so this is how we figure out the confidence interval. The question asks us, does the confidence interval give us a good information about the population of all cans in this case? Your answer for that case is no. The reason why is because of the conditions. Because in order for you to fulfill this, to use a t-sum test or t-test, or to use this t-distribution, you have to fulfill two conditions. The first condition says that your sample size has to be more than 30, but if you look at here, our sample size is way less than 30, so that's the reason why that this is not a very good data. Another thing is that it also has to be a simple random sample. This question does not have SRS, simple random sample, so that's the reason why that this is not going to be appeared to be a very good prediction here. So you know, because the sample is not SRS and the sample size is small. So in this case it's less than 20 or less than 30, so that's why so it's not really good. And next question is, does the sample appear to be from a normal distributed population? If not, how are the results affect? So in order for us to figure out if this is a normally distributed, you can draw a box plot or a histogram. By looking at the box plot here, let me do a box plot with a better view on here so you can see it. Horizontal equals true. You will notice that the box plot here is not normal distributed, it's actually skewed to the left because of the zeros. We have a few zeros in this case. You notice that we got like 1, 2, 3, 4, 5. Those zeros are it's not an outlier because it's not a dot in here, but it is make it skew to the left, so it's not normally distributed. So the sample appears to be normally distributed? No, because it skewed to the left due to the 5 zeros in the data. Now this data, the zeros are not outliers, however it will affect your finding in this case. So so it will affect your results in this case. So make sure that in order for you to fulfill this, make sure that 1, it has to be simple random sample, 2, sample size is small, or If you have a small sample size, which is fine, then what you need to know is it has to be from a normally distributed population. This rule is kind of a robust state where you have to either pick, if you have a small sample size, then you have to make sure that it is normally distributed in this case.